All right, guys. Okay, so you should watch the first video on the extrema, the degree, leading coefficient, the zeros, roots, all of that. So now we're going to talk end behavior. Okay, so with end behavior, we have these funky little, the funky little symbol of infinity. So I want to point something out. So when we're looking at this right here, which you notice will be on all of these end behavior questions. So that's just like the standard. So when we are talking about x going to negative infinity, all we're meaning is that that is the left-hand side of your graph. So if we have a graph, agreed that we have two ends. We have an end on the left and we have an end on the right. So instead of saying the left-hand side, this is what it's doing, and on the right hand, this is what it's doing, we do it this way. So as x goes to negative infinity, that means the left-hand side. And when we say as x goes to positive infinity, we're meaning the right-hand side. Okay, that's all that means. So that's going to be standard on all of your end behavior questions. Sometimes you're going to be given it like down here in the boxes. It's given to you. Sometimes you'll have to write it out. Okay, so you just understand that that never changes. That's always the same thing every single time. Okay? All right, so as we look at this, we've got 4 boxes here because we have 4 different things. Okay, so you've got to pay attention to this. So degree is even, and we have a positive LC, which is leading coefficient. So when that happens, when you have an even degree and a positive leading coefficient, okay, even degree means that your ends are going to be the same. Okay, so ends go in the same direction. Okay, that's what even means. Now positive, that means the right side goes up because it's positive. Okay, so when we're talking positive and negative, you'll notice that like down here in the second boxes, these are negative. Positive, negative, all that means is it's talking about the right-hand side of the graph. Where is the graph going as you read it from left to right? Okay, so as you can see, this is an example of even and positive. Okay, so I'm looking at this graph here. So as x goes to negative infinity, so that means the left-hand side, where is this graph going? Well, it's going up forever and ever and ever, so it's going to positive infinity. And if I look at the right-hand side, that is also going up, so it's going to positive infinity. We don't even need the graph to be able to know that, because we know it's even, so the two ends have to go in the same, so our answers for these 2 questions have to be the same. And then we know that it's positive, so we know the right-hand side goes up. So if the right-hand side goes up and is positive, then that must mean the left side is also positive. All right, so let's look at the one below. So on the one below, we've got even, but it has a negative coefficient. So again, even means that the ends go in the same direction. Okay. I just noticed that my bottom doesn't look right. Okay. Evens ends go in the same direction. And then if it's negative, that means the right-hand side goes down. Okay. All right. So I noticed down here, mine doesn't look right. I will fix it for you guys so yours should look right. So as x goes to negative infinity is what it should say. So I wrote this one a little different just because I wanted you to get used to seeing it. So as x goes to negative infinity, f of x goes to, remember, f of x is the same thing as y. They mean the same thing. Okay, so that's all. So just because it says f of x doesn't change anything. So if we know that the 2 ends go in the same direction and we know it's negative, so we know the right-hand side has to go down. So then we have, let's see. So scratch that out. Your paper should be correct, so don't worry about that. So the right-hand side is going down. So this is negative infinity. So that must mean that the left side also has to go down because it's negative. Okay? All right, we'll come back to domain and range. Okay. Actually, let's do domain and range right now. So domain and range. So 99% of the time, your domain is going to be all real numbers. So all real numbers. And then all real numbers. All right, if you have an absolute max or min, which is what happens when you have an even degree. So this has an absolute min here on this one. This one has an absolute max on this one. Okay? When you have an absolute or when you have an even degree, your range is just going to be a subset. So we say all of our y values are going to be greater than or equal to, and this coordinate point right here is -2, -20. So here, this is my y. So all of my y points are going to be greater than or equal to -20. So what that means is on this curve, if I were to pick any coordinate point on this curve, anyone, I can expect my y coordinate to be either -20 or bigger because everything is above this. Okay? Now, just the opposite here. All of my points here, all my y points are going to be below this point because that's my absolute max. So I would say y, all of my y's are less than or equal to 6. Okay? Because everything but my y values would be below that because my curve is below that. All right, so let's look at odds now. All right, so if we have an odd degree, so 1, 3, 5, 7, 9, so on and so forth. So the ends go in opposite direction. So opposite, odd, opposite, even, same. Okay? And then if it's positive, again, same thing. That means the right side goes up. Okay? So again, leading coefficient tells us what the right-hand side of the graph is doing. All right, so if we look at this as x goes to -infinity, which again, that means the left-hand side, right? Here's my left-hand side. This is going down. So as x goes to -infinity, y is going to -infinity. Now, because this is odd, right? Because this is odd, we know they go in opposite directions. So my two answers here need to be opposites of each other. So if this first one's -infinity, then I know this is positive infinity. You can also look at the graph to confirm that. Okay? All right. So then looking at down here, again, we have odd. So that means the ends go in opposite direction. Odd, opposite. And then this is negative, which means the right side goes down. Okay. All right. So again, I apologize for the mess up on here, but your paper should be fine. As x goes to -infinity, f of x is going where? So -infinity is the left-hand side. I can see that this is going up. So this is going to positive infinity. Okay, so it's going to positive infinity. Now, if I look at the right-hand side, so as x goes to positive infinity, which is the right-hand side, remember. All right, I can look on the graph and I can see that it's going down, but I don't even have to look at the graph because I know it's odd. I know these two answers have to be opposites of each other. So then this is -infinity. Okay? All right, let's look at domain and range on these. All right, so domain and range. Domain, again, is all real numbers for both of these. Now, because these go in opposite directions, one's going down, one's going up, I'm going to cover every y value there is. It just goes on forever and ever. So my range is also going to be all real numbers and all real numbers because the ends of the graph are going in opposite directions. So I'm covering all of the y-axis, even if the graph went on forever and ever and ever. Okay, so hopefully this was making sense. All right, let's look at these practice questions down here. Okay, again, I know my copy's kind of messed up, practice is cut up, but don't worry about it, yours should be fine. Okay, so again, as x goes to -infinity, so that's the left-hand side, my y is going to -infinity. And as x goes to positive infinity, that's the right-hand side, it's also going down. So remember, if it goes down, that's negative infinity. If it goes up, that's positive infinity. Doesn't matter which side of the axis it's on, as long wherever it's going. Okay. All right. So then this one I see is going up. So remember, this is left. So this is going to positive infinity, and my right one is going down. Okay. All right, I'm going to skip down to number 5. Let's look at it just from the equation. So the two things I'm looking at is I'm looking at degree and leading coefficient. Okay, so the degree is 3. So this is an odd degree, which means the ends are going to be opposite. So I know my two answers have to be different. My leading coefficient is negative, so I know the right-hand side goes down. So the right-hand side goes down to negative infinity. They have to be opposite, so that's positive infinity. Okay, again, looking at number 6, we're looking at the degree and the leading coefficient. So the degree is odd, so we know they're opposites. And then, oh, sorry, I'm looking at the wrong thing. The degree is not odd, I apologize. The degree is even, so the two ends go in the same direction. My leading coefficient is negative, so I know the right-hand side has to go down. So this has to go down. So then that means they have to be the same answer because they're even. So they're both go to negative infinity. All right, what I would like for you to do, and yes, I really mean it, I want you to pause the video, and I want you to do 3, 4, 7, and 8, and then check your work, okay? Please pause the video. Practice, then play the video. All right, hopefully you paused it. All right, so the answers here, this would be negative infinity, and this would be positive infinity, and here they would both be positive. For down here, we've got an even degree and positive, so they both go up. And here, we got odd and positive, so the right-hand side goes up, which means the left-hand side must go down because they have to be opposites because it's odd degree. So hopefully you got those correct. Now you need to work on the other worksheets that was given to you for more practice. If you have questions, rewatch the video or please ask.